So this is a quick overview of the components of the ActiveTwo system. We'll talk about each of the pieces starting at the participant end of things and working toward the software, and then we'll cover the software as a separate matter. So at the participant end of things, of course, we talked before in the video about the supplies kit, about the measuring tape. So the measuring tape is used to choose what size of cap you'll use. So most systems used for EEG will come with caps. Of course, you can record EEG without caps. It's kind of a separate discussion, but when you're choosing a cap to be used with the pin type electrodes, you'll be able to measure the head circumference and then choose a cap based on the circumference range that's in the cap on the label. So this cap is red. That tells me it's a medium, and it covers from 54 to 58 centimeters. So I would recommend this for someone with a 56 centimeter head. Anyone smaller than that might find that this cap is a little loose, or if the head is a little larger, you might find that it's a little bit on the tight side. So these caps do come in 2 centimeter increments, although the size range suggests that they cover a 4 centimeter range. I would aim toward the center of that range and be sure that you have caps that overlap in size, so that they are, so that you're able to choose the next size up if the person is kind of at the upper end of the range. In particular, that is important for comfort, so that people don't bail out of a study too early. So this is a 64 channel cap. This would be used with two 32 channel ribbons. This is this sort of a standard biosemi layout with 10-20 positions. It has a chin strap. Note that the chin strap on the medium and larger caps is 7-inch, and on smaller caps it's a 5-inch chin strap. So for adults who use the medium, be sure you're using the 7-inch chin strap, unless they're on the exceptionally small end of the range. Notice that at the back of the cap you have a tag. So for a 64 channel cap, or any cap that has an electrode down here low, you'll need to be sure that the tag is out of the way so that this site makes contact with the scalp. So you have a range of cap sizes. There's probably 15 sizes or more, all the way down to infant and all the way up to very large for adults. Many different cap layouts and actually even different fabric styles are available. This is a kind of a standard setup, and you'll see that it doesn't come down very low on the sides and in the back, and we can provide caps with lower coverage for visual studies if you're interested in that. So in the cap you'll be using these pin type electrodes. So the pin type electrodes are on a ribbon cable, and the ribbon cable is very fine wires. The electrodes separate out. Each one has 2 wires or 2 conductors. You have on the new ones this red rubber reinforcement. So this reinforcement is good for maintaining the integrity of the wire right there where the wire goes into the hard plastic housing. That's important because when they're placed in the cap, that point where the wire enters or exits the housing is the point of the most strain. So you want to make sure that that's protected. Partly that's a matter of orienting them so that the wire is facing the direction that it will naturally flow toward the back. But it's also helpful to have this reinforcement because the reinforcement protects the wire even when it's subjected to some strain. So you have pin-shaped electrodes which go in the cap, and then for measuring from bare skin, if, for example, around the eyes or at the mastoids or on the earlobes or on the nose, we have these flat type electrodes, sometimes referred to as TP flats, because the electrode is flat and the connector is touchproof. So the connector being touchproof means that the contacts are on the inside, they're not exposed. You can't accidentally be placed in contact with a power source, for example. Or on the torso for EKG, say one here, one down below, or on a pair of them over a muscle if you're interested in measuring EMG. So the flat type electrodes are sometimes also referred to as TP flats because the connector is touch-proof. It has a little bit of a key shape. The key shape is matched to the input on the AD box, so they plug in here on the front row. If you have the expansion head box, which is not shown here, you would have 32 of these inputs on a separate box that can also be used with these individual TP flats. So the flat type electrodes have labels EX1, EX2 up to EX8. You might find it useful to maintain those labels so that you know where to place them here, but also to place a complementary label that indicates the anatomical location at which these electrodes will be placed. For example, I generally recommend that the first one, EX1, goes on the left mastoid, the second one on the right mastoid. So that would be EX1 equals M1, EX2 equals M2. And then I go lateral ocular 1, so that's EX3, EX4 is lateral ocular 2. Then 5 would be, EXG5 would be inferior ocular 1, and EXG6 would be inferior ocular 2. So our numbers on the left, even on the right. So these have many purposes, but basically they are biopotential electrodes, so you can use them for EOG, for EEG reference, for ECG or EMG, or skin potential. So in addition to these, which are the measurement electrodes, you always need to have a CMS DRL. So the CMS DRL is like a ground. It is the common mode sense and driven right leg electrode. So the CMS is the common. So all of the measurements that you get from these active electrodes will be referred to the CMS. Don't think of CMS as the EEG reference though. It is the voltage reference in an electrical sense, but it is not the EEG reference. EEG reference is going to be whatever you choose. It could be a pair, one of these, a pair of these, or just the average of several. But the CMS is like the common. Think of it as being like the ground. So electrodes that are close to CMS will have a small signal, and electrodes that are farther away will have a larger signal in the raw data. DRL, on the other hand, because it's paired with CMS, is sometimes mistaken with the EEG reference. Remember that DRL is not the EEG reference. It is the driven right leg electrode. So its purpose is to drive the body to the center of the A to D converter. And by doing so, it reduces common mode interference by 40 dB. So DRL is driven right leg. It's like an active noise cancellation electrode. So we see that this CMS DRL pair is pin type, so I can put the CMS and DRL into the cap. But we also have flat type CMS DRLs. And this is not included typically unless you buy extra sensors. So if you were going to use the ActiveTwo system to measure, let's say, not so much EEG, but maybe sometimes you would measure EKG along with respiration and temperature and some other parameters, you might not want to use the head cap. In that case, you wouldn't have a place to put CMS DRL if there were only pin types that fit into the cap. So these flat type CMS DRL electrodes can be used with the double-sided adhesive rings that we showed in the video about consumable supplies. And they just need to be a couple of inches apart. Ideally, the CMS will be somewhere close to the array of electrodes. So if you're measuring from the torso, maybe you put CMS DRL on the torso. And DRL doesn't have to be anywhere in particular, but somewhere on the body. It's convenient for it to be close to CMS because the distance between these two is not so great. These come on a cable with a DIN connector. So this circular DIN connector plugs into the front of the AD box. So we'll go into more detail about CMS DRL in another video. So in addition to the electrodes and caps, we have the analog to digital box. Each system comes with 2 batteries, one of which is attached here below the AD box. the second battery with a battery charger and its power supply. So this is the charger and this is its power supply. We'll have a USB cable. Actually, each system comes with two different lengths. I always recommend using the shorter of the two USB cables to connect to your computer, unless you need the longer one. Longer cables are subject to potentially more interference, and so ideally you'd use the shortest cable. You also have a fiber optic cable, which is used to connect the AD box to the computer via the optical receiver or USB interface. So the basic setup is going to be fiber optic cable connects to the AD box. So this is an ST type connector, has a little bump. We're going to find the notch in the top of this and then push in on the ring and turn to the right. The other end of that cable, the fiber optic cable, will plug into the optical receiver. Has the same type of connector, push in, turn. And then on the front of the optical receiver there's a USB connector, so I'm going to connect the USB cable there. And the other end of this will go to my host computer. So this just needs a USB 2 port on the PC. On the back of the optical receiver is the trigger port. So included in the new systems for the last year or so is a USB virtual serial port trigger cable. So this longer cable with this small USB connector will connect to this little adapter. So one end connects here, and the other end will connect to the USB port on the stimulus computer. So when the driver is installed for this, and if your computer is connected to the internet, the driver should be found automatically. For Windows, it's found through Windows Update, and it will appear on the computer as a virtual serial port. So that means that in presentation or ePrime or MATLAB, you'll be writing to a serial port. Just remember that for this cable, you'll want to make sure that the baud rate is set to 115,200, 8 bits, no stop bit, or no parity, and 1 stop bit. So it'll be 8 in 1, and you need to set that in both Windows for the virtual serial port and in whatever software you're using to communicate with this. When you write to this a value between 1 and 255, it will come out the other end as parallel data. And the parallel data will go on the trigger channel within the ActiveTwo system. So using that high baud rate gives us a very high bandwidth connection and very precise and reliable timing as far as triggering. So this is a really good substitute for the old parallel ports that we used to use. And it's pretty much universal. It works with everything. There are other cables available, but this is the one that comes with the system as standard. So I mentioned before that there's a battery below the AD box. The battery is connected by a cable, and it is attached physically with these clips. So you can see that you set the AD box on top of the battery, lift up on these until they clip at the top, and you press down. And then you have one convenient package that you can move around. The spare battery should generally be connected to the charger. So we'll take this power supply and connect it at the wall outlet. Take the other end of it, connect it to the back of the charger unit. And what I usually do is set the charger on top of the battery, connect the battery cable to the charger. And what you should see is that the charger will go into a charge state. It started out as ready, now it shows charge, and because the battery was already charged up, it went straight back to ready. So that's a good sign, the battery is ready to go. So this battery should take from fully depleted to fully charged about 3.5 hours. If I went into an error state where the red light was flashing, it might take more like 12 hours. That would mean that the battery was too deeply discharged. That happens if you use it up to its limit and then you let it sit instead of putting it on the charger. So just remember that when the battery is fully depleted, the green light that comes on when you're using it will shut off, and then the red light next to it, called shutdown, will come on. When the battery is in shutdown state, meaning that the red LED on the battery itself is illuminated, it's in its most fragile state. So you want to make sure that if you see the red shutdown light, that you go ahead and connect the battery to the charger immediately, because it's in its most fragile state. If you let it sit like that, then it will continue to lose charge, and then if it loses continually more charge, it will be unable to be recharged. So that's the best possible way to damage a battery, is to let it sit too long in the shutdown state. So my advice is that it's safe to keep the battery connected to the charger when you're not using it. Keep the other one on the AD box, because when you're reviewing the signals in the EEG recording software called ActiveView, you'll be able to see the state of the battery, and you'll know how much charge you have left. Work to about 20% remaining on the battery, which is indicated by the low battery status on the top on the AD box. This red LED is on the AD box rather than on the battery itself. When you see low battery, then work to a close and switch batteries, and you'll put this one on the charger and this one on the AD box. So you'll always have one that will give you about, for a 64 channel setup, 12 hours of runtime, and from fully depleted to charged about 3.5 hours if it doesn't go below the say 15 or 20% range. So let's discuss the properties of this end of things briefly. So the optical receiver is receiving digital data over the fiber optic cable. So remember that this path is completely immune to picking up interference. So this can be quite long. The standard cable that we provide is 10 meters. But it could be a mile long and it wouldn't matter. The signal would travel over great distances without any loss. Included in that data stream is not only the EEG data, but also the clock. So when I turn this AD box on, if this is connected to a computer, the green LED next to the optical cable will light up. That LED indicates that the clock signal from the AD box is being received here. So along with the EEG, we have the clock signal. So what's important about that is that the clock signal also drives the trigger port. So if you wonder how do we know that the EEG samples are timed precisely with respect to triggers, on the receiving side we know that because this port is clocked by the same clock that clocks the EEG samples. What is harder to know is whether or not the trigger was set at the right time from the stimulus software. So for that reason, timing questions usually don't center around the EEG apparatus so much as they do about the sending apparatus, the stimulus software or device that you're using. So I would recommend when you get to the question of timing tests that you think about an oscilloscope as the right mechanism for doing those kinds of tests, not the EEG apparatus itself, because its timing is assured by this clock relationship between the AD box and the optical receiver. So another thing to know about the AD box is that it really only has one control. So the battery has the power switch on it, so you can see if it's not connected and I turn the battery on, nothing happens at the AD box. But if I turn it off, connect it and turn it back on, the AD box comes on. So the power switch is actually on the battery and not on the AD box. The only control you have here on the AD box is called speed mode. The speed mode dial is this little ring right next to the power connector, and in between the power connector and the fiber optic connector. And speed mode sets the overall sampling rate and which channels are sampled at that rate. So in the standard setup, speed mode 4 would give us 2048 samples per second per channel. And that's the minimum bandwidth that you can get from the AD box. So it's going to give us all channels at 2 kilohertz sampling rate. And For ERP, that's typically too high. People usually want a smaller data file or fewer samples. So if you want a lower rate than 2 kilohertz, you'll have to decimate the incoming samples on the receiving side. So the ActiveView software allows you to do that. So before you start collecting, you want to make sure that the speed mode dial is set where you want it to be. If you never move it, then it's not going to change on its own, but it is set usually at speed mode 4, and 4 designates 2 kilohertz. If you were to increase it to a higher rate, it would go in powers of 2, so 4 is 2 kilohertz, 5 is 4 kilohertz, 6 is 8 kilohertz, and 7 would give you 16 kilohertz. There are other speed modes available for special applications. For example, the high-speed firmware option would give you more speed modes with the same speeds but more channels at those speeds. So that's one thing I didn't mention, is that as you increase the speed mode here and increase the sampling rate, the number of channels that you can sample does decrease. With this high-speed firmware, you can record more channels at these higher rates. So CMS DRL is the leftmost connector, and then these other connectors are typically unlabeled. AUX2 and AUX3 would be the labeling, but they don't have the red tags to indicate something else. If you have a red tag, on mine I have Ergo and I have GSR Pleth on the center one. So these inputs require electronics on the inside of the box. So inside of the box, one of those added channels would have another module. So when channels are added, whether the channels are for EEG or sensors, there's going to be a module that looks like this that's installed inside. This is an 8-channel module, so to the naked eye these all look the same, but in fact the modules for other sensors other than biopotential active electrodes, such as the ones that serve GSR Pleth, temperature, respiration, other things, those modules are specially modified. So they'll fit in a specific slot that's labeled for that purpose inside the AD box. And between the motherboard and the front panel there'll be a special connector. So the one that is in there, if it's labeled AUX2, AUX3, is just a placeholder. When you add a sensor, you'll get a special connector like this with a little cable set that plugs into the motherboard to connect the front panel to the motherboard to provide that extra signal. So that's how these boxes can be adapted to include other non-EEG signals, whether they be other physiological measures or analog inputs.